So last week, we talking about the digestion systems. We just finished half of it. Today we continue it. So digestion systems, there are mainly functions: digestion and absorption. So that's generally function of digestion system: digestion and absorption. Digestion means make the big pieces of the food breaking down to small pieces. So digestion, basically, we have two different kinds of digestion. One is physical digestion. That's the same idea like when we use knife to cut the food, but just like use our teeth to cut the food. And also by our digestion tract contractions, still can breaking down the food from big pieces to small pieces. But the chemical structure, nothing changing. So that's the physical digestion. Another part, we're talking about chemical digestion. Chemical digestion is truly chemical structure is changing from big complicated structures changing to simple structure and easily for us to absorption. So absorption, the food, it must be small, simple, contracture kind of food. It's not like a big food, more complicated chemical in there. So we only can absorption simple. We're talking about some detail later today. For absorption, what kind of nutrition we can absorption. And that's the basically two main functions of our digestive system. Mainly absorption for nutrition, and certainly absorption for other things, including the water, vitamin, and minerals. And the unused part, we talking about the waste part released from the body. So that's our basically digestive system and the function. Then we're talking about the digestive systems. It's composed by two big parts. One big part is digestion tract. Sometimes we can use like a channels, tubes. So basically, like we know, it's something around there and hollow inside. So that's digestion tract. So that start from the mouth and then go down, go to our salt area and esophagus area, then stomach, then small intestine, large intestine, and finally ending on the end. So in that part, we release something we couldn't digest or couldn't absorption. So that's the food or nutrition passing the route. That's one way directions from upper go down. And another part is organs. Organ also is glands. It is secretion digestion juice. including some enzymes. So that's pretty important for food chemical digestion. So it is directly related to the digestion tract and mainly digestion, chemical digestion, happens in the digestion tract. So that's basically we talking about the two parts of our digestive system. So make the chart here, make everything look like a simple here. So we say digestion tract start from the mouth and then go down. That's one-way directions, normal. So esophagus, stomach, small intestine, we also including three parts here. And then large intestine, we even including more parts here for large intestine. At least ascending, transferred, descending, and digital. And another part we say organs, or maybe we can use the word gland. So that's the part with secretion, digestion juice, and some enzyme inside. Salivary gland, we have three. That's the bigger one in the salivary gland. They all of these three open to the mouth. Secretion, digestion, juice, especially for starch. Liver secretion for the bile. That's mainly help our fat digestion. We will talk about later. We say normally people eating only 2 times or 3 times daily. They need help to digest only after the eating. But the liver producing the bile continually. If we are not needed, they store it in the gallbladder, and then when we need it, they immediately release. So that's normal condition. So we put the liver and the gallbladder together. So basically, gallbladder don't have their special functions. They are not secretion anything. They just store it for the bile and release. So that's why in the Western medicine, sometimes people got gallbladder infection or even gallbladder stone inside. So truly, people can live without gallbladder. That means the liver producing the bile, they will directly release to small intestine. They still connected to small intestine and open to small intestine. But the problem is when people not eating, the bile go to there, continually release. They are not useful. Just follow like our digestion liquid, we call that chemi kind of movement, directly go down and totally relieve from our stool finally. But after we eating, we need digestion. People will not enough the bile to help the digestion, especially if people eating some fatty food. That will cause the poor digestion. So generally speaking, if some patients got gallbladder removed, the doctor will tell him, don't eating too much oil food. So any kind of food, if you can taste lot of oil inside, they may hard to digest it and cause other issues. So that's the liver and the gallbladder and their function. Pancreas is even more important. Help us digest it. They have a lot of enzymes, and they producing digestion juice. They can help digestion almost all the nutrition. So that's pretty important for our digestion. So that's people couldn't living without pancreas. And also we know pancreas, another important part, belong to endocrine system and the secretions hormones and balance our internal sugar level. One hormone increase sugar level, one hormone decrease the sugar level. So that's pretty important, help our digestion. So that's we talking about the organ and glands. We have special kind of shape in there, and certainly name in there. But truly, in the past couple 10 years study, people find the small intestine. Inside the small intestine, they still have some glands in there. They still secretion, digestion, juice, and enzymes in there. But they are not special kind of form. Mainly part still like a pancreas and the liver. So that's generally our digestive systems picture here. So that's last week we discussed not a lot of detail about digestive system. Last week we also talked about a special word, bolus. What means bolus? Just the food look like a ball, and the food mixing with the saliva, and easily were passing through from the mouth, passing through the esophagus, and finally go to the stomach. So that's the word. And another word here just mention the movement of our digestive system. That truly pushing the food go down from pharynx, go to esophagus, and finally go to the stomach. And this kind of movement even we use for other part of the digestion tract, like the stomach, like small intestine, even large intestine. So that just means our digestion tract contractions and moving the food go down. So that's the bolus moving down from upper go down by the smooth muscles contraction in here, make the space more narrow, and then pushing the bolus go down. Then the contraction in this area. Contraction in this area. And then pushing the food go down again. And then contraction go to this area. It's like this picture. And pushing the food go down. Finally release to the stomach. Esophagus, nothing special. This food passing the route. Something happens in the stomach. Yeah, something happens in the stomach. So the stomach mix everything together and throwing or mixing everything. And we have physical digestion certainly happens in there. And part of chemical digestion happens in there. Chemical digestion part is produced by the protein digestion enzyme. That means they can digest protein. So that happens in the stomach, yeah, only for protein, only for protein. Then we talking about another word, chemy. Chemy is some semi-liquid in the stomach area. So basically, it's the food mixed with digestion juice. It's not solid. It's not totally liquid, like half liquid in there. So that's what we call chemy. So it leaving to stomach, go to small intestine in that form. So that's chemy. So small intestine, we say that's more important part for all digestion. So that's basically we have a lot of enzymes in there, and we can digest for like almost all the nutrition, protein, carbohydrate, fat, and they helping with the liver relieve the bile, and the pancreas relieve some digestion juice, help each other. So that's all digestion in the small intestine. And we say most absorptions happens in the small intestine. So that's why small intestine shape, superficial area is pretty bigger because they have a lot of fingers like kind of projections there. We call villi. Just like this picture here. So the small pieces, small intestine coming from here, and then we make enlarging. They like a finger shape in here. And then in each of the finger shapes, they still have a lot of fingers. That truly increase the superficial of the small intestine area. So that we say we are easily absorption nutrition, and the cells in the small intestine wall is single cells in there. So just like here, inside of the fingers of the blood vessels and the lymph vessels here. And then around it, just the single cell line here. So that helps our absorption. So food just inside pretty easily passing through single cells go to blood circulation and go to lymph circulation. Then large intestine mainly function relieve waste produced. Anything couldn't digest it passing through and relieve. But truly, large intestine have another important function: reabsorption of water. So water secretions to the digestion tract from different parts. We're always talking about digestion juice. So look like a start from stomach to the small intestine, and then moving to large intestine. So semi-liquid kind of stuff inside. We need a reabsorption. If we are not reabsorption, people will lose a lot of body fluid, will cause body dehydrated. So that's reabsorption water is another important function of large intestine. And also we say some special kind of bacterium, it naturally living in large intestine. And they can produce some special kind of vitamins. And they help the vitamins absorption. So that's some function in the large intestine. So that's large intestine, ascending colon, transverse colon, and descending colon. So that's basically is last week we talking about. Mainly we talking about digestion tract. Start from the mouth, go to the arm. Today we go to the organ part. Organ part, we also name it gland. So the first organ, we go to the liver. So function of the liver. Liver, everybody know, it is located on the right side of the abdominal cavity, below the rib cage, below the diaphragm. And truly, some rib cage can cover part of the liver. On the right side. So that's the liver's location. And the liver has a lot of functions. It truly can help our digestion. We say it producing the bile and help to digest fat. But they have some other functions. So we talking about function of the liver here. We including other functions of the liver, not only for digestion. So liver is the storage area. That's storage especially for glucose. What means glucose? Single sugar. So our body directly can use as the energy. It's coming from the simple sugar. They can turn it to ATP. and we directly use ATP as a body energy. So that after your eating, certainly some part go to all over the body and we use it. But if you are not like immediately use that much, we're still talking about people eating twice or 3 times daily. But certainly any kind of physical activity, they will use energy, they will use glucose. So they must have some place to store it and then use for other time when you're not eating. For example, at least when you sleep. When you sleep, you use less energy compared with daytime. But thinking about your heart still beating there, you still automatically respiration there. Where the energy coming from? It's coming from the storage of the energy. So our sugars, they coming from our food. They travel to from small intestine to the blood. And then from the blood circulation go to the liver and store it in there. Our blood sugar level should be keeping in some range. So basically, we calculate by different unit. That's before we calculate. But right now, like people under 6, they just calculate by different unit. If too high, will cause other damage, like diabetes kind of patient. They may damage their blood vessels. They may damage their muscles, or even like cause more easily infections. So we keep the blood sugar level in some range. And after we eating, certainly our blood sugar level will be increased. And our hormone regulation. You remember insulin function. Insulin secreted from the pancreas and released to blood circulation. They mainly function decrease blood sugar level. How they decrease blood sugar level? It's the mainly part sending the blood sugars go to the liver and then change the form glucose. It's kind of an inactive kind of form. And when people need it, like between your eating, you still use your energy coming from the sugar, and then your blood sugar level falling down below the normal. Then liver cells can changing it back, changing glucose to glucose again. That's still single sugar. Still we can directly use it. And that kind of sugar released to blood again, then sending all over the body to see where needed. So that's basically it's important balance of our blood sugars level and storage for the sugars for we life needed. So that's the first important one, storage for glucose. Second important one, second important function of the liver. Producing blood protein. We know in the blood plasma, mainly we have three big proteins. Yes, three big proteins. All of these three proteins is producing in the liver. So we can see how important of the liver. People couldn't live without protein. The first one, albumin, that's only in the liver. Only producing in the liver. So that means if liver losing the function, people, these kind of proteins will be pretty much decreased. The second one, globins. Half of the globins produced in the liver. Another half producing by the blood cells. Yeah, we have a special kind of blood cell, lymphatocytes. So that can produce some of the globins. And the third one, does mainly function help us to stop bleeding? That's still only producing in the liver. So that's we're talking about if patient have liver problems, their blood proteins level will be decreased, and especially decreased for albumin. And also patient possible easily cause bleeding problems because their protein help to stop bleeding is decreased. So that's another important function of the liver. So now we mix liver, all the functions together. Even we are talking about digestive systems, but some function not directly relationship with digestive function, but it is very important function of the liver. And another function of the liver, producing urine. So that's a waste product. It coming from our digestion of the protein, or after we using the protein. It's coming from protein metabolism. So these part truly not useful. Then they will be released. But they changing to this form, then they can release. If they are not changing to this form, they will not release. So that's synthesis in the liver, and then release to the blood, and follow the blood circulation, go to the kidney, finally release from our urine. So certainly, these kind of function have disorder that still can cause the trouble. So basically, that look like a toxins inside the body. If you couldn't relieve from the or urine from the kidney, that will toxin mainly for our central nervous system, cause patients kind of crazy kind of condition. So still very, very important for our life. So still continue. So how important the liver it is. We have lot of functions here. Modification of the fat. So the fat still kind of energy. So basically, if we need to use it, they need to change to the sugar. We say sugar is the energy we can directly use it. But other kind of nutrition must be changing to the sugar, then we can use it. So how we change it? It happens in the liver. So we say liver look like a big chemical factory inside of the body. Without the liver, people couldn't live. Yeah, people must have liver. We can remove part of the liver if they have sick or illness, but people couldn't remove all of the liver. Sometimes we do liver transplant, but need to matching like blood type and also organ type. But liver is so important, so important. People couldn't live without liver. So that's another function. Then we relationship with digestive function. So even we say liver belong to digestive system, but truly liver's function more than only digestion. So for digestion part, producing the bile. So that's relieve to the small intestine and then help to digestion. So that's important part. And another function of the liver, we talking about blood cells before. We say red blood cell living time 120 days. After 120 days, the old blood cells go to the liver and these structures in there, and then relieve some unuseful part and recycling some useful part. So basically, some pigments will be released from the cell. And they eliminated in the bile. That's the main part. And these kind of ligaments, so basically we have a special name, and passing through from small intestine to large intestine, finally relieve in the stool. Thus give us stool's color, some dark yellow color in it. In other words, if this part losing function, basically it's not only losing function, it's kind of bile duct blocking. That's our gallbladder here. That's our small intestine here. That's stomach here. So basically, we say bile relieve to small intestine. That's normal. But usually possible cause like we talking about gallbladder stone, and then falling down, blocking the gallbladder tube here. So that's truly the bile couldn't relieve to the small intestine. So these kind of patients, their stool could be white color. Totally no color. So that's another function of the liver. Not finished yet. Yeah, we have more functions. So how important the liver is. Another functions, detoxins. Remove some chemicals or toxic stuff. So like people always drink alcohol. So alcohol mainly is a toxin for the people. So they can damage nervous systems if people drinking too much or too long time. So basically it's changing in the liver, changing to other form and then release. And also if some people using lot of medications or drugs, that kind of chemical still the toxins released from the liver. Then liver also storage for some vitamins and iron. So that's if people, let me say, have red blood cell deficiency and hemoglobin deficiency. So basically in China, I'm not sure in here, we will suggest the patient who eating some animal's liver. So in the liver, they have a lot of iron. So basically can help build up red blood cell. And also patient have eyes problems. We still suggest patient to eating some animal's liver. We can have pigs, sheep, and liver. So they containing lot of vitamins, yeah, especially vitamin A and D. So that's benefit for the eyes. So that's we talking about the function of the liver. So liver function not only help to digestion, they also have lot of other functions. So that's the like liver look like, and the bile is under the liver, So that's a pretty important part of our body organs is the liver. Then we go to talking about something specially for the liver, for digestion function. We go to more detail here. So we say mainly digestion function of the liver is producing the bile. And the bile's functions basically help to digestion for the fat. The bile working with the salt together and then when changing the fat, breaking down to small droplets. So this kind of small droplet is easily digested by the digestion enzymes. In other words, digestion enzymes without bile's help is pretty hard to digest fat. With bile's help, they are easily digested. And also after digestion, the bile also helps absorption of the fat. from small intestine. So that's basically bowel function. With a bile producing in the liver, but normally storage in the gallbladder, and then we need it through the duct, release to small intestine, and getting working. So that's basically we're talking about digestion of the fat. Basically, help fat digestion and also absorption. Gallbladder will still belong to digestion system, but gallbladder itself is not have its special function. We say it is just like a muscular kind of sock in there, and just use storage for the bile. So we say liver producing the bile continually, continually producing the bile. It's not have special time and producing and stop. It continually producing the bile, and we need it only after we eating. Like usually people eating 2 or 3 times a day. We need it only after we eating because they help to digest it for fat. So then the bile coming from the gallbladder and released to small intestine. Other times, they just from the liver. And we talk about when can we go to the first part of the small intestine, that is there, and then gallbladder contraction. When gallbladder contractions, pushing the bile and go to small intestine and help digestion. So that's the liver and the gallbladder and the function. Mainly focus on the liver. Liver is more important part, not only for the digestion, also liver have some more function. Then we're talking about pancreas. Pancreas is another important organ in the digestion system. We say pancreas producing lot of enzymes. Certainly, when we talk about pancreas, we immediately know that belong to 2 systems. One part belongs to digestion system. Another part belongs to endocrine system. We finished endocrine systems already before. Now we're only talking about digestion function in pancreas here, but truly they belong to 2 systems. So pancreas producing enzymes. That kind of enzyme can help to digest almost all the nutrition, everything, fat, protein, carbohydrate, and the nucleic acid. That's the mainly important part can form the cell's nucleus. So these kind of enzymes, when they just produced in the pancreas, they are in active form, pretty similar like we talking about the stomach. stomach enzyme produces still in inactive form. Otherwise, they will digest itself. So these kind of enzymes, and then they travel to the small intestine. And then in small intestine, they changing to active form. They triggered by other enzymes. We talked about before. Some enzymes it can produce it directly from small intestine. And also the pancreas producing big amount alkaline kind of fluid. We know the chemistry coming from stomach to small intestine. That's basically is acid because they have a lot of acid secretion in the stomach. Then we go to small intestine, and the small intestine pancreas can secretion big amount of alkaline kind of fluid, so they are neutralized in the small intestine. So that's basically kind of way protection for our digestion tract. We say only stomach can handle more acid because they special kind of structure and they have special kind of mucus to protection superficial of the stomach. Other part of digestion tube is more thinner and not that stronger protection. So we need neutralize. So basically go to small intestine. The chemical will be neutralized. So that's the pancreas. Then we see the location of the pancreas. Yeah, pretty close. You can see the pancreas. This part is a little bigger. It's like a holding in the small intestine. That is more air. So that's we call the height of the pancreas. Middle part, we call the body of the pancreas. And the ending part, we call the tail of the pancreas. The pancreas tube go all over the pancreas, and then they meeting together, and finally they open to small intestine. Most people, they have one tube little bit bigger, another small tube little bit smaller. That's for most people. They have two open to small intestine, and they release digestion juice to small intestine. So that's the pancreas. And inside the pancreas, inside the pancreas, we say it belongs to two systems. Like we take small pieces from inside the pancreas and use special kind of scalp, like electrical kind of scalp, make it larging and larging. Finally, we can see the picture like this. So in the center part, a group of cells in there. We have 3 different kinds of cells in there. So that belongs to our endocrine system. And around the part, still group of the cells together, but in the center, they have 2. And another group of cells together in the center, still have 2. So these tube, these tubes, they meeting together, finally open to small intestine. So that's a lot of tubes meeting together, finally form two bigger tubes meeting to small intestine. So that's this group of the cell truly producing digestion juice, including the liquid. So that's all for pancreas. Belong to digestion part. So that's basically we finish the organ part. The organ part truly inside the mouth. We still have 3 glands in there, but basically we're talking about from beginning part already. So that's just as mean can digestion for start. That happens in the mouth. So if we summarize, the digestion organs here, salivary gland only digestion for starch, and the liver and we didn't separate with the stomach for digestive functions because that mainly is the tube there. But truly stomach can digestion for the protein. I'm talking about digestion here, mainly talking about chemical digestion. Certainly, physical digestion start from mouth. So stomach can digestion for the protein. Salivary glands digestion for the starch, or other words, we can say sugar. And other digestion juice secretions by the pancreas, but truly liver relieve the bile, and the bile can help to digestion for the fat. But the pancreas relieve the digestion juice will digestion for all the nutrients, including the fat, including the sugar, and also including the protein. So the pancreas is another important organ. We just talking about the liver is important organ. Pancreas is another important organ. Still, people couldn't live without pancreas. And the pancreas also easily cause the problem, like inflammation or even cancer, because they secrete so much enzymes, and that's also easily caused by digestion issue, caused like acute pancreatitis. So that's basically our organ part of our digestion systems. Then we especially talking about digestive functions here. We got some thumbnails here. So we say digestive functions is we separate with physical digestion and chemical digestion. So before the food absorption, we must be digested, and then food can absorption. food couldn't absorption without digestion. So physical digestion, yeah, we're talking about the physical digestion first. So physical digestion is still important. So that's basically just breaking food from big pieces to small pieces. And then mix it with digestion juice. And by the muscles contractions, yeah, digestion tract, muscles contractions, and then pushing it go downward along the digestion tract. And after nutrition absorption, some unuseful part or waste part is eliminated. So that's the physical part. Physical part still important because the big part or big pieces of food without physical digestion or chemical digestion is a little bit harder. It still can do it, but it's harder. Small pieces is easily for chemical digestion. So physical digestion, including patients' juice food, that firstly happens in our mouth with our teeth and cut food more to small pieces. Thus, people say if you try to keep your digestion system healthy, you try to eating slowly, do it a little bit longer time. So that truly help your digestion later. That's the mainly part happens in your mouth for physical digestion. You cut it more small pieces, it will be more easily digested later. It happens like in the stomach, in the small intestine. So try to eating a little bit slow, not too fast. If you too faster, one thing, the food is not totally cut to small pieces. Another thing, they are not mixed with digestion juice in the mouth. We know in the mouth, it's kind of chemical digestion happens already. And then after juice and mixed with digestion juice, people swollen down, and then digestion tract contracted. So that's mainly for our physical digestion part. Then we're talking about the chemical digestion part. Chemical digestion part is the chemical structure changing. And the chemical digestions, they truly broken down the large kind of chemicals and to small kind of structure of the food. So that's easily for our absorption later. So bigger kind of chemical, we're still not able to absorption. So what means absorption? Absorption means the nutrition passing through digestion tract in intestine mucosa, go to blood circulation, or maybe go to lymph circulation. That means absorption. So only small things can absorption. Bigger things still couldn't absorption. So that's another important part, even more important compared with physical digestion. So chemical digestion even more important. So chemical digestion happens by the enzymes. Without the enzymes, chemical digestion not happens. It's just like a stomach contraction there, small intestine contraction there, just physical movement in there. Only by the enzymes, then the chemical structure can change from bigger one to small one. So the enzymes, they are in the saliva, in the mouth. Thus, we say they can digest for the starch. And they coming from stomach juice. They mainly digest for the protein. And they also coming from pancreas juice. Pancreas juice can digest for a lot of nutrition. Look like all the nutrition can digest from pancreas juice. Certainly the juice contains a lot of enzymes. And also the bile. Bile contains a lot of chemicals. They can help to digest fat mainly. And we also some juice coming from small intestine. Intestine juice can also help digestion, especially they can active enzyme coming from the pancreas juice. So that's our chemical digestion part. Then we especially talking about different kind of nutrition, like after chemical digestion, what kind of small like chemical they will be formed. The first they will talk about carbohydrates. Carbohydrate is a big part of our nutrition, like the starch and the sugar. So that's basically our after digestion and absorption. It's our body can directly use it as the energy. So we say the starch is start from chemical digestion in the mouth, salivary gland secretion enzymes. Thus, can working with carbohydrate or starch. It happens in the mouth, in the mouth. So we say carbohydrate digestion start from the mouth, but it's not that effective because usually people put food into the mouth just a small time, and then they swallow down. So that's we say it able to, but not truly too much chemical digestion happens in it. So that's another reason we're talking about. Try to eating a little bit slowly. Keep your food in your mouth a little bit longer time. That truly can help with carbohydrate nutrition digestion in there. So after people swallow the food down, we say esophagus, nothing special. Just the food passing the route. Salt air, still nothing special. Stomach juice, they don't have special enzyme for digestion for carbohydrate. So carbohydrate start digestion in the mouth, and then they need to go to the small intestine to continue digestion in there. So in small intestine, the digestion juice, especially coming from the pancreas and coming from intestine juice, they have enzyme. They can digest for the carbohydrated stuff like starch and the sugar. So we say the enzyme coming from pancreas, that's the enzyme's name. And then start like digestion for carbohydrate. They will changing from the starch to double sugar first. Like we have something pretty bigger. We cut for some bigger pieces first. Then from the bigger pieces, we cut more smaller pieces later. So that's firstly, they changing to the double sugar. And then the enzymes coming from intestine, they can digest double sugar to simple sugar. So simple sugar, we call it glucose. So glucose is the single sugar. Double sugar basically like a double in there. But starch or other carbohydrate is many in there. Many. So that's the ending products of carbohydrate after digestion is the single sugar or glucose. Single sugar or glucose. So we are not only have one formed single sugar, but most single sugar is the glucose. So that's why sometimes we just use glucose instead of the simple sugar. But truly we have some other kind of form. But that's mainly is glucose. So now we know if patient talk about glucose, that's the simple sugar. Simple sugar. That's the mainly form with absorption, and the mainly form we test the blood sugars level in the blood circulation. What we test? Glucose. Glucose. So that's we say that's the ending digestion products for carbohydrate, glucose. Then we're talking about the protein digestion. Protein digestion, like we talking about before, it starts in the stomach. That's the enzyme in the stomach. In the stomach juice, and they can broken down big protein to small protein. So that's basically happens in there. We say usually these enzymes, when they producing in inactive kind of form, and they can changing to active kind of form, like the actin, by the acid, stomach acid. So that means it only happens in the cavity of the stomach. And it only happens like when people after eating normally. But that's by people regular eating. Basically, inside the body, we have clot. We may not notice it, but truly we have clot. Like if you regular eating the meal in the same time, basically the time before you eating, digestion juice start secretion, prepare for food already in your stomach. So that means if you are not eating regularly, sometimes early, sometimes late, your stomach, your nervous system will be confusing. So they may secretion some digestion enzyme and release to the stomach, and then they will be active by stomach acid. And if in that time you are not eating food, so what are they digesting? They will directly like digestion for your stomach. So that's why some people irregular eating easily causes digestion ulcers. Maybe the ulcers happens in the stomach. Maybe the ulcers happens in small intestine. That's because they have a lot of enzymes. These kind of enzymes in the digestion system, it truly can digest of our body structure. That not happens often because we have some protection in there, and they're automatically regulating in there. But if like we don't have special schedule for our life, your nervous system will be confusing and will cause some damage. So that happens in the stomach mainly. And the protein digestion also happens in small intestine. We say that's the mainly place of digestion happens in there. And also the mainly place absorption happens in there. So in the small intestine, we have some other enzymes. So that enzymes can digest for the protein. That's coming from the pancreas juice, and also can coming from our small intestine. So in there, our protein be finally digestion. Then we see what's the final product of the protein. So we say protein made up by the amino acid. So that's the structure of the protein. They join together and form the protein. So when they try to digest, basically we speed it up. So that means finally digestion production of the protein is amino acid. So we just separate long length of the protein, lot of amino acid there, and separate it. It go back to amino acid. Certainly, the chemical structure might be different for different kind of protein. We have a lot of different amino acids. So with digestion, we just separate amino acid. And then we directly absorption is the amino acid. So that's the basic block we build up of our body. So we know inside the body, we need protein. We need protein. Lot of like structure need protein. Firstly, our muscles. Firstly, our muscles. We need protein. Build up. Mainly is the protein. And also some cells. Some cell structures. They still need protein. For example, we talked about before. Cells have the membranes, have cytoplasm, and have nucleus. So membrane part, we still remember we have protein channel. We have protein channel. So we have a lot of protein in the membrane form working as protein channel. And the cytoplasm part, we have pretty smaller organelles inside, like a small organ inside the cell. They still need protein. They still need protein. And also inside the nucleus, we have axon. Axon is a combination with the protein in there also. And also in the blood circulation. With blood circulation, we have blood plasma. We have cells. The cells part we talked about already, including any kind of cell. Blood plasma part we say mainly is the water. But we still have some protein circulation. What is that protein doing? Like we talked about before, blood system. We say they can performing transform functions, transforming like some ions, some nutrients, or even hormones. And they also can produce some protection functions, working as antibodies. And it also helps to stop bleeding. We have special kind of protein that help stop bleeding from the blood clots. So that we can see how important of our protein. We are the protein, like we need so much of the protein perform both body functions. So where the protein coming from? Mainly coming from our food. Mainly coming from the nutrition. With digestion, protein, and broken down to the amino acid, then we absorption, then rebuild up of our bodies in different parts of the body from different parts, different kinds of the protein. So that's normal. So that's we talking about how important of protein to build up of our bodies. So that's clinically sometimes maybe people have some trouble if they're vegetarian. I don't say vegetarian is totally wrong thing, but truly the people vegetarian, they lose a lot of chance to take protein. Certainly, we suggest people can take some protein from the plants, like the beans. Beans is pretty good protein, pretty good protein for the vegetarian kind of protein. But the beans have some troubles. If you're directly cooking or eating beans, it's a little bit difficult to digest. You must be cooking longer time. So otherwise, whatever you eat, it will not digest, certainly not absorption. And the tofu is pretty good. Yeah, tofu is pretty good. It's coming from the beans and easy digestion. Some people vegetarian, they may still can eating some eggs, so that's good. Yeah, or maybe fish. Yeah, that's still good. So generally say, animal protein is different with the plant protein. So that's we talking about finally is amino acid, but the different amino acid. So that's still if people vegetarian, they eating some plant protein, they may still missing some like special kind of protein. They contain some special kind of amino acid. So that's easily cause people like poor nutrition. So that's one aspect. Another aspect, some people say, oh, I know protein is good. I know protein is good. I try to directly eating some protein and to build up our bodies. Like patient talking about make the face look younger. Yeah, I think that's a special kind of protein. They will in some special kind of animals. Yeah, like the children always have like the face looks pretty 44, pretty younger there. But truly, we know that protein, whatever protein you're eating, it's not directly go to inside the body, not directly build up your body. They must be digested. We just say that's pretty close, yeah, pretty close there, amino acids. But not truly you can directly use it. They must be broken down to amino acids. And then they build up again for the protein you use. For some they put a lot of words for different kind of nutrition, but sometimes it's used. So that's about our protein. Then about the fatty, fatty. So three big nutrition. Yeah. Usually we talking about three big nutrition: carbohydrate or sugar, carbohydrate or sugar, protein, and fat. That's three big nutrition. Yeah, three big nutrition for our body. With the sugar, our body can directly use, like a glucagon. Our body directly use as energy. We directly use the form is ATP, but it can directly coming from the glucagon. And protein mainly build up of our body. But truly, they can change each other. In some special kind of needed. Yeah. So that's why sometimes people talking about they only eating protein, but they still like the blood sugar level still not totally dripping down, still in there. So that's because inside the body, the nutrition can changing. Still remember our liver is a big factory there. The liver can do lot of things. Even we talking about a lot of liver function already, but we still not including everything liver can do. Liver can do even more. And the fat is kind of storage kind of nutrition. Still can change into the sugar, and they still can change into the fat. So when people didn't eat too much carbohydrate, and then inside the body they can like automatically changing each other and like suitable for our body usage. So we say the fat digestion must be helped with the bile. It happens in the digestion, the first part of small intestine. So fat working by the bile changing to fat droplet. And the fat droplet easily for the digestion further. So after it happens to small droplet, big droplet, small droplet, and then our pancreas lupus. That's one kind of enzyme, especially digested fat. They can change in fat to fatty acids and groceries. That's the final product of the fat after digestion. So that's about the fat. So that's three big nutritions. Three big nutritions: chemical digestion. Then we're talking about absorption. So after food digestion, it will be absorption. We say food absorption, it means the nutrition is moving through the small intestine, mucosa membranes, and to the blood circulation and the lymph circulation. So that's nutrition coming, moving from small intestine to the blood or maybe the lymph. So what kind of nutrition go to the blood? What kind of nutrition go to the liver? We like to say most nutrition will go to the blood circulation. That's the most part. Nutrition go to blood circulation. And we still remember like the liver receive the blood supply by two parts. One part certainly coming from the artery. Another part coming from the portal vein. Where the portal vein coming from? Digestive system. Yeah. So certainly mainly part small intestine, certainly including other parts digestive system. So we say the portal vein carry the nutrition from the small intestine, then sending to the liver. And from the liver, they branch it. It's like the artery branches there. So that's basically we say chemical reaction happens in the liver. It's coming from nutrition part from the small intestine absorption. So we say absorptions, yeah, food absorptions, they only can absorptions for single kind of nutrition. What means single kind of nutrition? We just talking about after protein production, digestion, they form the amino acid. After carbohydrate digestion, they form the glucose. And after fatty digestion, they form the two parts. So that's only fatty, they form two parts. Protein and sugar, they only form the same name. But truly amino acid, we have lot of different forms. And they form this kind of a single production there, and through the wall of the small intestine, then go to our blood circulation systems, mainly. We're talking about mainly here. Then we see what kind of nutrition go to blood circulation, what kind of nutrition go to lymph circulation. So we're still talking about the structure of small intestine. We still remember that kind of single line of cells in there, like the fingers, pretty big superficial space here. And each of the single finger kind of shape in there we call alveoli. So that's pretty big superficials in the small intestine and help the nutrition absorption. So the absorptions, pretty simple nutrition. They directly pass through from the cells membranes, and the nutrition like salad, yeah, and other nutrition. Still remember when we talking about the material passing through the cells membranes, we have active kind of way, active kind of transportation. need ATP help. So that's the most the way we're talking about our nutrition to transport. So basically, glucose and amino acid means coming from the carbohydrate and coming from the protein, like sugar and the protein. They will directly passing the cell's membranes by the active canal transport to the blood circulation. But the fat, final digestion, production, they will go to liver. So basically, because fat is chemical structures is a little bit bigger. Even we're talking about like after totally digestion, they form two small kind of chemical structure in there, but still bigger compared with amino acid and glucose. So that's why mainly the absorptions go to liver system. So that's basically our digestion system. We use 2 weeks. We're talking about our digestion systems. We're talking about its structures and also their functions. Mainly focus on function part, and especially for 3 nutrition. So that's our digestive systems.